Normal distributions. A smooth, symmetric, bell-shaped curve which approximates a binomial distribution is called a normal curve. That is a normal curve. It looks like a bell and it is smooth, and all the amounts or the numbers under this curve is called the normal curve distribution. Which means that if I have a group of people, the probability of having a tall person and a short person and a normal person would be distributed. If it is normally distributed, it will look like that. I will have the majority of the people in the middle, and then I will have some short people, and then I will have some tall people at both ends, and the majority would fall in the middle. Now, let us see the distributions. How do they look like? The middle part is my mean, and then one deviation to the right, one deviation to the left. This part would have 68% of the people I am testing, or the amount of people I'm having a survey on. If they are following a normal distribution curve, then they would fall in this part. 68% of the people would fall into this part. The second deviation would have 95% of the people. And then the third deviation would have 99.7%. So the total area under the curve would be 100%. The first deviation would have 68%. The second deviation, both right and left, would have 95%. The third deviation would have 99.7%. Example 1. A normal distribution has a mean of 56, which is the part in the middle. We said that the mean is the one in the middle. And a standard deviation of 8, which means that if I go one deviation this side plus 8, one deviation this side minus 8. That's what we have here. First deviation on the right, I'm going to have 68. One deviation to the left, I have 48. Find the probability that a randomly selected x value is in the given interval, number 1, between 32 and 40. Where is 32 on my normal distribution curve? 32 is this last part. So it is between 32 and 40. So it is this part here, which is, this is my first deviation, this is my second deviation, this is my third deviation. So it is between the second and the third deviation. We said that the first deviation would have 68%. The second deviation would have 95%. And the third deviation would have 99.7. So this falls between the 99.7 and the 95. But only on one side. So I'm going to have it divided by 2. So it is going to be 2.35%. The second part, at most 64. At most. The maximum is 64. So anything less than the first 64 is available. What is less than 64? 64 is my first deviation on this side, while the whole curve on the second part. The whole curve is what? I divide with my mean the curve into two equal parts, 50% and 50%. So for the first percent, from the lower 50%, I will take it all, because it says here, at most 64, at most. My maximum is 64. So anything less is okay. So I'm going to have 56, anything less, which is the 50%, okay with me. And then the second part, from 56 up to 64. So what is that part? That is the least part, the one deviation. What is one deviation? It is 68 on both sides. So on one side, I only need 34, which is half of it. 68 divided by 2, which is 34. So I'm going to have 34, which is this part here, and then plus the 50%. Together they make 84%.